Okay, and now we're getting to the trickiest part of this lesson, where we're trying to write slope-intercept form from a variety of different information. Sometimes we're going to be given 2 points, sometimes we'll be given a point and a slope, sometimes we'll be given an intercept and a slope, or a point and an intercept. We're just given a variety of information, and we have to figure out how to use that to find our slope-intercept form. And the biggest thing I can say is that we're using this equation to figure out what we're missing in that equation. We're using parts of it to figure out the missing part. We're going to have 3 parts of it. As long as you're savvy about the problem-solving part of it, you're going to have 3 parts of it, and then you're going to be able to find the 4th part. So we're trying to figure out the equation of a line, the y equals mx plus b, for a line that passes through that point and that point. So right now we only have 2 coordinates. The big thing that we can find from those 2 coordinates is the slope. We're not able to really find the y-intercept from this. This is the x-intercept. So that's like 1, 2, 0, and then -1, -1 is there. A line that passes through there is hitting at some decimal y-intercept that we can't really just estimate. We have to find that. We're going to use algebra to find that, but we're not able to just look at the graph and figure that out. We're given the x-intercept, and we're given just a random point, -1, -1. We can use that to find the slope. So we're going to start off by just doing that. We're going to use y2 minus y1 over x2 minus x1 to at least get us started and find the slope. So I'm going to use 0 minus a -1, and 2 minus -1. That would give me a positive 1 on top, and 3 on the bottom. 2 minus -1 gives us a positive 3. So we at least have part of it here. We have our slope. And actually, we have everything that we need to solve for our y-intercept. We really just need 3 parts of this equation. And we have those. We have 2 sets of coordinates, and every coordinate is really just an x and a y combination that we can use in this equation. That's a y, that's an x that we can actually replace with a set of coordinates. I'm going to use that one because that one looks a little bit easier to use. 0 is generally going to be easier to use. So I'm just going to plug in to this equation. Y equals mx plus b. I have my m. I have one of the numbers I need here. That's 1/3. And then I have my x and my y, which is 0 and 2. I don't have the b, but that's what I'm looking for, so I'm actually in good shape. I have the 3 numbers that I can use to solve for the missing part of this equation. So I'm going to simplify this side first. That 1/3 times 2. So 0 equals now 2/3 plus b. And now I can solve for b with just one more step. I'm going to subtract 2/3 over. Right now that's being added to b. It's a positive 2/3 that I'm trying to cancel out. I'm trying to cancel out a positive 2/3, so I subtract 2/3 from both sides. That would give me b by itself on this side. B equals, and 0 minus 2/3 is a -2/3. So I have my b, -2/3, and I have my m. That's 1/3. That's all you really need to write the equation. So I'm going to write my equation out as y equals 1/3 x minus 2/3. You find your m and your b, you have your equation. Usually your first step is going to be to find the m using 2 coordinates or an intercept and 1 set of coordinates. But if you have a set of coordinates, an x and a y, and you have your intercept or your slope, you can find the 4th part of that equation. All right, second one's saying a very similar thing. We're trying to find a line that passes through that point and that point. Okay, so again, I'm going to use that same equation. y2, 1 minus y1, that's -1, over x2 minus x1. That's 1 minus 4. That could be 2 on top and a negative 3 on the bottom. I'm going to change that into negative 2 over 3. In general, when we write the slope, we're going to put the negative sign on the top. These are really the exact same thing. It's also the same thing as writing it as just negative 2/3. Those are all the same thing. In general, when you see a rise over run, you're going to see it as negative 2 on top over positive 3 on the bottom. Now we're going to use that in our equation. Y equals mx plus b. And I'm going to use my x and y combination. It looks easiest. I'm going to use 1 and 1 with my slope to find the missing part, the b. So I have 1 for y. That's this number. I have 1 for x. That's that number. Times negative 2/3. That's my slope. Plus b, which I don't know what that is yet, so I'm going to leave that as a variable. I'm going to simplify the right side. Negative 2/3 times 1 is just negative 2/3. And then I'm trying to cancel out that negative 2/3 that's being added to b. It's negative 2/3 that I have to cancel out. So I'm going to add that over. Adding 2/3 to a negative 2/3 cancels it out. If I do it to one side, I have to do it to the other. So that would give me b equals 1 plus 2/3. 1 is just 3 over 3, so plus 2 over 3 would give me 5 over 3. If you don't feel comfortable writing that as an improper fraction, you could write it as a mixed number, 1 and 2/3, or you can write it as a decimal if you really want to. Most of the time you won't see decimals in problems like this. You'll see them written as fractions because slopes are usually written as fractions. I'm going to write it like this, but it's all the same any of those three ways. So you have your 5/3 as your b. We have our m, which is our slope. That's a negative 2/3. So we really have our equation. That's negative 2/3 x plus 5/3. On number 3, they're talking about a line that passes through 3, 3, and an x-intercept of negative 1. This is very similar to the previous two problems, so I'm just going to get you started on this. The x-intercept of negative 1 is really just a set of coordinates. It's negative 1, 0. So it's really the same thing as 1 and 2, where you have to find your slope, and then use that slope in our equation. Y equals mx plus b. You have your x, you have your y, and this will tell you the m. You plug each of those three into that equation to solve for b. I'm going to do the same kind of thing on this next one. Actually, this next one is probably the simplest of these four. They're telling us the slope. It says the slope is 1/3, and it passes through this point. They're telling us a bunch of information here. They're saying that we have an x and y, and we have our m. We have all the pieces that we need. Y equals mx plus b. So we have 7 as the y. We have 1/3 as our x. 1/3 is our m, our slope, and 3 is our x. That makes it pretty easy to solve for the b. I do want to go over 2 from a graph. So I'm going to go over numbers 5 and 6. And this is probably the clearest way I have to see that I'm not going to be able to just look at the graph and figure out my b. But I can look at the graph and figure out my m. My m here is going up 1, 2, 3. That's a rise of 3 and a run of 1, 2, 3, 4. So my slope here is 3 over 4. So we have our m. But we don't know our b yet. But we do have an x and a y. We can use this point as the x and y to plug into that equation. This is really just the point -1, -2. That's an x and a y that I can use in that equation. So I'm going to use -2 as my y, 3/4 is my x, and negative 1. Sorry, 3/4 is my m. It's my slope, and negative 1 is my x. So now I'm really just trying to solve that equation for b. I have to multiply these two together first, so that's negative 2. And I'm going to multiply these two together first. That's negative 3/4 plus b. I'm trying to cancel out a negative 3/4. So I'm going to add 3/4 to both sides. That's going to cancel out. And negative 2 plus 3/4. You can write this in, again, a variety of ways. Negative 1 and 1/4. Negative 5/4. Or negative 1.25. I'm going to keep it as a fraction. I'm going to write it as an improper fraction. Most of the time, that's how I'll write my answer. Either way, it tells us that our b is that number, and it tells us our equation is 3/4 x minus 5/4. You do want to confirm that you're kind of on the right track at least. You can't know for sure what point that's hitting at, but you know it's a little bit less than negative 1. Like negative 1 is there, negative 2 is here, and negative 5/4 is somewhere in between negative 1 and negative 2. So at least we know we roughly solved that equation right. It's also a positive slope, so we know that this number has to be a positive number. The last one, we're going to do number 7 together. So I'm looking again for that slope and y-intercept. Again, I can't really see it from the graph, but I know it's somewhere in between 3 and 4. So I should get 3 point something, or 3 and an extra fraction part. Let's find the slope first. So I'm counting from this point to that point. That's going down 1 and over 1. 2, 3, 4. Down 1 and over 4. That's my slope. Negative 1/4. The b here is going to be whatever we solve for there when we plug in the slope and one of those coordinates. Doesn't really matter which one. I'm going to use this one. That looks like that's at negative 1/4. So I have 4 as my y value. My x value is negative 1, and my slope is negative 1/4. Now all I need to do is solve for that b. I'm going to multiply these two together. That gives me a positive 1/4 now. Cancel out a positive 1/4. You have to subtract 1/4 from both sides. This cancels out. This would give me 3 and 3/4. You could also think of that as, what is it, 15/4. So my b is 15/4, or 3 and 3/4, or 3.75, which kind of confirms that we're doing it right. That makes sense as 3.75. So my y equals my slope, which is negative 1/4, times x plus 15/4, which is the b. Again, that makes sense. This is a negative slope. It's going downhill. And my y-intercept is at least roughly correct there.